this. Y equals ax squared plus bx plus c. Vaguely remember that?
Yes.
Okay. When you guys graph those, you're right. They were parabolas. Okay? They were all parabolas. They were either up like a cup or down like a frown. And that direction was based upon the coefficient of A. A was positive, up like a cup. A is negative, down like a frown. Pretty easy. What you guys did with these is that for every one of these equations, they all had the same starting point. You always found this axis of symmetry. You always found this axis of symmetry. Hi, how are you?
Yes, how are you doing?
I'm great. Wonderful to see you.
Yeah? Sorry, I don't think to see you.
Nerds. With these parabolas, you're something. This symmetry occurs. This axis of symmetry is this imaginary vertical line that for every point on one side of the parabola, there is a point exactly the same distance on the other side. In order to find this axis of symmetry, there were always the same equation. X equals the opposite of b over 2a. Like I said, this stuff was really stinking easy. I'm going to put up an example with just straight values and walk you through how I would graph. So let's use y equals x squared, 8x, and a 15. And then we'll make it easy. Yes, ma'am?
Do we have to do these on graph paper?
No. Because really I'm only looking for a couple of things for these types of graphs, and you'll see what I'm getting at here. When I'm going to graph this, like I said, the first thing I'm going to do is label. What's A, B, and C? It's kind of it's something you don't really need to do, but I've found that by putting this down on paper, it will alleviate me from making a silly mistake later. What's A?
1. Yeah, 1.
One.
I'm sorry.
It's a good thing we're writing this down. So you have 1, 8, and 15. Straightforward. Go to that axis of symmetry. Is the opposite. It's always x equals the opposite of b over 2a. Well, b is 8. What's the opposite of 8? Negative 8. So you get negative 8 over 2 times 1, which is negative 4.
Wait, what does the AOS mean?
Axis of symmetry.
Thank you.
Welcome. Now watch what happens when you have this axis of symmetry. X equals a number is always a vertical line through that number. So these axis of symmetry really is an imaginary line. That's why we just kind of dot it. Here's why we find that. The axis of symmetry, the vertex of every parabola lies on the axis of symmetry, which means you already know what the x-coordinate is for this parabola. It has to be negative 4. The vertex will always lie on the axis of symmetry. So if I know my x value's got to be negative 4, what do I do to figure out my y value? You do the forward. Substitute.
Oh, yeah. I get it.
So all you have to do is use your calculator. What was it?
You do the function.
Negative 4 quantity squared. Notice I'm putting parentheses around the negative. What was it? 8x? I get a y value of negative 1. I think you were talking about using the y equals button,
Wait,
which is fine. This is it's just another way of going around it. Yes, ma'am. It's not on the x-axis. It lies on that vertical, that x value. And the vertex has to lie on the axis of symmetry. Because the vertex for every parabola is either going to be the highest point or the lowest point. Everything else around it is going to be going up like a cup, or it can be falling away down like a crown. That symmetry line, that axis of symmetry, will always, always, always encompass the vertex. Always. Otherwise it won't work. So once you figure out that opposite of b over 2a, that is the x-coordinate of your vertex. Every time. Okay. Oops, that's right. So let's do that. And I got -1. So I have -4 and -1. In what direction is this going to move? It's moving upward because the a value is positive. So now the reason I'm using this axis of symmetry is because now I can find one other set of ordered pairs that are called symmetric twins. Pick any number to the right. Let's use -2. In your calculator, do you guys know how to overwrite values? Have you figured that out yet?
No.
Go back up to, hit your enter. Oops. Okay, so we'll, oh, that's right. I forgot. I was thinking I was on a multi-view. Duh. This one you hit second enter, and it will pull up what you just typed in. Yes. I took the calculator.
No, I mean like, what did you?
Sorry. I pressed the button that said on.
Keep going. I'm so glad it's not me.
I'm sorry. What I did was I took this and I substituted for x.
You just plugged it
I didn't do electrical work. I substituted. All while being a bit of a smart butt. So once I pull that back up, I'm just going to hit the left arrow and just overwrite the -4 and make it a 2. Your calculators are so much faster than the operating system on this thing. This thing's a piece of work. So when it's at -2, I'm at 3. So this is allowing me to have ordered pairs. Bless you. -2, 3. The axis of symmetry tells me that this point is how far from the axis of symmetry? 2. So I have to go 1, 2 over here, and guess what's here? Another 3. It's called a symmetric twin. They fold in on each other. They're the same distance away from the axis of symmetry on both sides of the parabola. Always. They're always big. Each point has a symmetric twin. Always equidistant. And that's what the axis of symmetry allows you to do. Okay? That's all you really need to worry about. So Shimke, do you need graph paper for that? Oh. You need to be able to put axis of symmetry on there, vertex, and a set of symmetric twins. That's it. Yes, ma'am. Because I picked -2 for my next value, that's all. I chose another value of x. So it's -2 and 3, which means this is at -6. That's all. You can pick any value. If I pick 0, I know it'll be at 15 because 0 squared plus 0 is plus 15. So 0 is 4 spots away, which means the other symmetric twin would have been at -8 and 15. That's all. I'm just picking easy numbers. The other two ways that we look at graphs now are going to be vertex form and intercept form. Let me show you vertex form. Vertex form. You'll recognize this. Bless you. A, H, and K. Again, it looks very similar to when we did absolute value. That when we had the H and K with the absolute value, it told you where it started. Same thing here. when you have something written in what's called vertex form, the value of h and k, well, that is your vertex. Where do you think your axis of symmetry is going to be at? Where? No. Where's that?
At the vertex?
Well, it'll go through the vertex, but what will it be? Where? At h? I didn't know if you said a or h. That's why I said at h. Because what is your x coordinate here? H. So what happens is you get this equation, y equals, well, let's do this, 2x plus 3 quantity squared plus 1. If I go through that, what is my vertex? Good. Negative 3 and 1. Remember, it's the opposite sign for the h. So my vertex would be at negative 3 and 1. So when I go to start plotting this, that's my vertex. Is it going to open up or down? It's going to open up. Where's my axis of symmetry? My axis of symmetry is at x equals negative 3. It is always going to be the x coordinate of the vertex. Always, always, always. Yes, ma'am. Oh, yeah, yeah, yeah. And just like I said earlier, if we know that that axis of symmetry is right here, all we have to do is find one set of symmetric twins. Make it really easy on yourself. Well, let's use 0 or negative 1. Any one of them. What do you want to use? Use negative 1? Okay. If I use negative 1, what's negative 1 plus 3? What's 2 squared? What's 4 times 2? What's 8 plus 1? 9. So I know that at negative 1, the other ordered pair would be at 9. So negative 1 is 2 spots away, which means I'm going to put another one 2 spots away over here at 9. Zoop. Very, very simple and easy to use. Yes, sir.
What is it?
A represents kind of like a how fast and how narrow it will open. It's similar to what slope is, just like we did with absolute value. The higher the number, the steeper it was. When you have a quadratic with a coefficient of that's greater than 1, it becomes a little bit more and more narrow, a faster rise, as opposed to more of a fraction, you have a fatter opening. It's sort of.
What practicality do parabolas have?
Oh, just wait. We're just starting.
I like, you know, just like in a 3-year.
Oh, okay. There's a problem in the book that deals with cannons. And let's say you wanted to fire a cannon, shoots a parabola, and you know how far it is, and you know maximum heights that it can be. If you know the maximum height of something, you'll be able to find out how far it's going to be able to go. So you'll be able to know where you set your rays. So warfare is a good example. Okay. Pyrotechnics, a lot of stuff. Or if I were to throw a ball and it's thrown on an arc, and I know the distance in which it's going, or a pitching wedge that's going to land a certain far, how far out it's going to go. There's a lot of stuff you can do with this parabola stuff. The other form was called intercept form. And this one looks a little bit different. I don't know if you've seen it written out like this before. Intercept form deals with the zeros of a function. We'll talk about that here in a second. You get this. Y equals a parentheses x minus p x minus q. And what this means is that p and q,
You gotta mind your P's and Q's.
I don't know what that means.
bless you, where p and q are the zeros of the function. What that means is where they cross the x-axis. And I know that each and every single one of you guys have dealt with a problem like that before. At least I hope. For example, if I do this, y equals x squared plus 8x plus 12. And I want to find my zeros. That means I have to factor that and set it equal to 0. Vaguely remember that? Now, I factor things a little bit differently than some other people do. I always go the same method each and every time. I look at to multiply the tails to add to the middle. What's the coefficient here? What's 1 times 12? So, what times what is 12, but I add together to get 8. 6 and 2. Okay. I know there are so many different ways of going about it. I always go this way every time because it always works. I don't do those box methods. I don't go into any of that. If you want to use the box method and go for it, go. It doesn't matter to me. I'm just going to use the method that I was taught because it works.
What is the box method?
I know who you are. He's the one who taught me this.
Oh, okay. I was going to say,
I got it.
now, when you're trying to find zeros, what you're doing in essence is figuring out what makes that function 0. So you set it equal to 0. So what plus 6 is 0? Negative 6. What plus 2 is 0? So your zeros are at negative 6 and negative 2. What this means in terms of a parabola is that on a graph, it's crossing the x-axis at negative 6 and negative 2. This is intercept form. It tells you exactly where they're going to cross. And the other thing that's nice with this is that since those values are on the same y, that means they're equidistant from some middle point. So what's halfway between negative 6 and negative 2? Where do you think your axis of symmetry is going to be at this point? At negative 4. You have an axis of symmetry at the midpoint.
Yay!
So now you know your axis of symmetry for this style problem would be at negative 4. When you're in intercept mode, it's the midpoint of the zeros. Your axis of symmetry is at midpoint of zeros. Okay?
Sorry.
It's okay. So if my axis of symmetry is at x equals negative 4, what's the x coordinate of my vertex? Negative 4.
Wait, what did you ask?
I said if my axis of symmetry is at negative 4, what's the x coordinate of my vertex?
Oh, okay.
Negative 4. So now what do I do to figure out the y value?
Math.
Math. I substitute in. What's negative 4 plus 6?
2.
2. Negative 4 plus 2. What's 2 times negative 2?
Negative 4.
There's my vertex. And then don't I already have one set of symmetric twins?
Yeah, we did.
It's kind of working backwards. You start with twins, get your axis of symmetry, and then your vertex. That's it. And you're done.
Math is so fun.
What's up? It's not that difficult at all to work with either one of those methods. It really isn't. To be honest, I think intercept form is the easiest because you've got your symmetric twins ready to go. Finding a midpoint is nothing. Just add them together and cut it in half. The a value when it's in intercept form, if you look at the equation that we had, that x plus 6, x plus 2, my value of a in that case was 1 because there wasn't anything there. There might be some multiplier that will help you open and close it a little bit more here or there. But the whole idea, Mr. Pope?
I should go.
What's that?
Never mind.
The whole idea of being able to work with any of these forms, especially as we get going, is being able to do this. Being able to factor. Being able to factor quickly and efficiently is the name of the game. You're not sitting there on your calculator trying to multiply all this stuff together and go through that. You need to know your facts. You need to know your times table. So move some stuff off of your desk. Now, no. Leave these down.
These are dumb.
Oh, are we gonna fill in a multiplication table as fast as we can?
Oh boy!
Oh boy, Daddy, this is gonna be
So fun. I only know 12, so
You don't need to know
nobody
your
will have 12.
Yeah, problem.
negative numbers
It's gonna be It's a 0. Yeah, wait.
Hey! There's no cheating. I didn't say it's no.
Oh, do I get to
Am I allowed to put my name on the back?
Leave them face down.
Do I put my name on the back?
No. We need Charlie. I got. Here you go. Well, yeah, we're
Are you
racing.
6 or 12? Duh.
I was the best in
Are you gonna participate? Oh, I got one. Okay.
On your marks.
How long do we have? Wait, is it a race?
Get set. Whoa!
Here
Go!
go!
Ah!
Game over.
You gotta be efficient, ladies and gentlemen. You gotta be efficient.
Jesus Christ!
Oh, I love doing this. I almost got beat today. For the first time, somebody was only 6 spots away from me. That was the closest anybody has ever gotten to me. I have been doing this every year.
Legitimately scared the crap out of me.
Did you hear everyone scream?
Oh, I love it. Anyway, the whole idea.
Literally did.
You guys don't have to finish that now. Hey, the idea behind that now, I know, go ahead and get your stuff back out here. The idea of doing this is so that you can
Oh man.
It's really to prove your
factor quickly. Okay? It's knowing your times tables. It's knowing the relationship of numbers quickly. If you can do this stuff quickly in your head and walk through them, you're going to be fine at it. And guys, multiplying and adding, it's stuff you learned long time ago. But factoring is something that we still utilize. It doesn't go away. We will factor later on this school year with trig functions as well. All this stuff comes back to play. So if I'm looking at something like this, where it's x squared minus 12x minus 28, I'm always looking at what multiplies to the tails, that adds to the middle. So what times what is negative 28, but I add it to negative 12, I add and get it to negative 12. Negative 28 to get negative 12. Couple things you should start to recognize in your head. I know that if I'm multiplying two numbers together, one of them it's going to wind up being negative. That means they're both different signs. Okay? With it adding up to the middle number being negative, that means the larger absolute value one would have to be negative. Oh, sure. What is it?
Negative 14 and 5.
Yeah, perfect. It's negative 14 and 2. That's it. So when you write it out, x minus 14, x plus 2. Does it matter which one goes first? Nope. Not at all. Not at all. What changes if the problem had this in it? Nothing. What's your last step then, JC? Yeah, you would solve it. And this would be the thing where you're solving for those zeros. So just like we did a second ago with the intercept form, what would be my zeros for this? What are the zeros for that? 14 to negative 2. That's what it does. Yes, sir?
I don't know how to, well, I sort of know how to like, how do you know, like, because, okay, x minus 14, x plus 2, right? I messed up and I got x plus 14, x plus 2. That was just me being stupid. But
No.
most of the time, I'll be like, okay, which one is the negative,
Okay.
which is the positive? How do you know?
What you're doing here is, once you get to the 14 and 2, because that gets you 28,
Yeah.
okay? If you have negative 14 and positive 2, you add them together, you get negative 12. If you have positive 14 and a negative 2, you get positive 12. So you mess with the signs to see which one's going to give you the right middle term. That's all you're doing.
Okay.
Okay, that's what you wind up doing. So if I'm looking at it like that, or what times what's negative 21, but I add together I get 4. Negative 3 and 7. Perfect. Does it matter which one goes first? Get off your phone.
I want to check my grade on the test.
I don't have them in yet.
Why not?
Because I told you earlier, I'm not done with them.
You should be.
That's all it was.
Man, finish.
Okay. What changes then is when you throw in some of the special pattern ones. For example,
X plus 3 and x minus.
yep. This is what you call a difference of squares. Okay? When you see something like this that's just two terms with a square, you ask yourself the exact same 3 questions each and every time. Is this a perfect square?
Yes.
Yes. Is this a perfect square?
Yes.
Is this a subtraction symbol? Did we answer yes to all 3 of those questions?
Yes.
What's the square root of x squared? What's the square root of 9? One's plus, one's minus. Okay? That's all it was. Can you do it with this?
Sure, yeah.
Is 4x squared a perfect square?
Yes.
Yes. Is 25 a perfect square?
Yes.
Yes. Is that a subtraction symbol?
No.
No. So you don't factor it.
Oh,
It won't work.
what?
Think about it. There's no middle term here, correct? So that means my value of b is 0. So this is asking you what times what is 100 that you add together to get 0.
Oh.
And if you want to think about it as being 10 and negative 10, if you add those together, you get 0, but this would have to be negative because you have two different signs. That's why it doesn't work. All right, what about this one? X squared plus 8x plus 16. We'll make it really easy. Obviously, something like that's very easy to work with because you have what times what's 16 that you add together to get 8. 4 and 4. So this is your what's called a perfect square trinomial because you can rewrite it as x plus 4 quantity squared. There's a shortcut to that. Sometimes you might recognize it, sometimes you won't. To be honest with you, I rarely look for the special pattern when my coefficient is 1. I will worry about my special pattern when it looks like this. I don't remember the number, I'll have to look it up. There we go. Oops. Look at this. Your book is notorious for changing variables all the time. X, Y's, A's, R's, Q's, T's, whatever. It's all the same. It's a variable. You will see me 9.5 times out of 10 just rewrite it when I do the problems with an X. So if you start with one variable and all of a sudden I'm writing X, there's nothing wrong. It's just I don't like your book. For that matter. I should say. Well, the book isn't bad. It's just old. It's not really terrible. Here, we would have to multiply your tails together and go find a middle term, and I'd do what's called factor by grouping. That method's a little bit long and it's kind of arduous to get through, but what I want you to recognize here is 9y squared a perfect square?
Yes.
Yeah. Is 16 a perfect square?
Yes.
All right, what's the square root of 16? 4. So the square root of 16 is 4. What's the square root of 9y squared?
3y.
What's 3 times 4? Double it. Is that your middle term? It's a perfect square trinomial. What happens here? What's happening here is if you wind up with perfect squares on the tails, if their square roots doubled equal the middle, it's a perfect square trinomial. It's a nice shortcut pattern if you recognize it. If you don't recognize it, is it the end of the world? No. It just takes longer to math. That's all. How do I do what? How do I go the long way?
Yeah.
I'm going to show you with one that you have to go the long way. No, that's fine. This is the method that most people hate because it takes time. So in this case here, I've got 3x squared minus 17x plus 10. Oh, I totally forgot to mention the first rule of factoring. What is the very, very first rule of factoring? Do you remember?
Make sure you can get rid of stuff.
The stuff. What's the stuff? You're on the right track.
Like if you have like a 3x and then 3 squared and then 9x and then like a
GCF is what you're looking for. He's exactly right. The very first thing you always look for, no matter what, is GCF, greatest common factor. Do they have anything in common? If they don't have anything in common, just start falling through the rest of the tricks. Here they have nothing in common. Also, I have this leading term coefficient that's not equal to 1. I do this a little bit differently than others. The method I use is like, I think they call split middle term. It takes a minute or two longer, but it forces you to get it right, okay? It forces you into doing it correctly. So what's 3 times 10? 30. I need to figure out what times what's 30, but I add together to get negative 17. Perfect. Negative 2 and negative 15. Everybody hear that?
Yes.
So what I'm doing here is I'm going to take this middle term. I'm going to rewrite it in two parts. So I get 3x squared minus 15x minus 2x plus 10. Does it matter which one I put first? No. There will be a trick to why I always put a negative first, if I can. If they're both negative, you're kind of, well, you just have to be careful. Now, when I have 4 terms of a polynomial, what I'm always going to fall back on is grouping. I'm going to group them. I'm going to group the first 2 terms, and now I can find the GCF. It's 3x, very good. If I factor out a 3x, I'm left with x minus 5. Okay. One thing that I will do with these, if my third term winds up being negative, I force myself to do this, the same change opposite, when I go to group it. That way I'm reminding myself that I need to factor out the negative. So this is a little trick. You don't need to. If you recognize it, you'll be okay. But suggestion, do it. What's the GCF of 2 and 10? 2, but I'm going to take out the negative 2. Very good. Right. And you should get the exact same thing that you got the first time around. Because if you do, you're right. So do we have the same thing in parentheses?
Yes.
Yes.
Write it down. And what's left?
3x plus 2.
And you're done.
And it's coming back to me.
It takes a minute or two longer than the normal methods, but it'll always work for you. It'll always, always work. What time will you know? This is 5-2, right? Let's try another one like that. 2x squared plus 5x plus 3. First rule of factoring would have been to look for a GCF. Unfortunately, in this case, there isn't one. So I'm going to multiply my tails. So what's 2 times 3? Excellent. Hopefully we all got that far in our times table sheet. So what times what is 6? But I add together and I get 5. Convenient. Okay? Which means my middle term then becomes 2x squared, 2x, 3x, and a 3. And now I have 4 parts, which means I'm going to try to factor by grouping. Shove your headphones on. What do these guys have in common? 2x. I'm left with x plus 1. What do these guys have in common? 3. And I'm left with?
Wow, that's super easy.
Are these the same in the parentheses?
Yes.
Write it down. What's
What
up?
do you do with the square? Is it like 2x squared?
What's that?
Like 2x squared?
I took out, see, it was 2x squared and a 2x, which meant the GCF was 2x, so I... You don't play basketball, do you? Good thing. But I just took the GCF out. Okay. And now, since the x plus 1 was the same thing, what's left over?
2x.
And you're done.
Yay!
What changes when I do this? 1 second.
Nothing.
Nothing. What are your zeros with that function?
-1.
1.5.
What negative 3 has? Good.
Oh. What?
What were you going to say?
Wait, that's
So-
what I said, but if I
I'm probably just gonna get us all confused.
No.
But how does this work exactly? Like,
What do you mean?
like, I mean, I watched how you like tore it apart and everything.
Yeah.
But like, How do we know that that proves true for the function? Like, are we,
Foil.
does it just?
Because you can always FOIL it back out. What happens here is that you can always FOIL it back out to see what you get.
Okay, it's just like a faster way of doing it. Thank you.
Well, this is how you FOIL out.
Yeah. Look. Yeah.
So you have your 2x squared, 3x, 2x, and a 3. So you have 2x squared, 5x. It's how you go from this to this, and then to go back. What is the opposite of dividing? What is the opposite of subtraction? What's the opposite of FOILing? Factoring. It's their inverse operations of one another.
There we go.
That's
That-
why it
you-
works.
That you finished that.
Okay.
100%.
What I want you guys to do tonight, we're on 2 sections. It's section 5.1 and it'll be section 5.2. In 5.1, I'm only going to have you do a couple of the graphs because it's just real fast ones. We'll worry about some fancier graphs later. Let's see. So this is on page 253. It was number 24, 30, and 36, I believe. Just those 3, one of each style. Okay. We'll get more fancy with it later. 5.2. I wanted you guys to. Yeah, 24, this is page 260. These were the 3 graphs, these are factoring. 63. Every third, okay? It's 5, it's a dozen, okay? It's a dozen factors. Maybe 11, sorry, okay? It's a lot of them aren't coefficients. Some of them can't be factorable, some of them can. Watch for them. Every third problem, yeah, my place is 24, 27, 30, 33, and so on. It's like the middle column. I don't have a lot of the fancier ones in there. We'll get into that later on. Good times. Sorry, I scared you. That's awesome. Great.
I'm sorry I cussed Mr. Murphy. That just
No, that's fine, and that's